Good morning, guys. Today we're going to look at a comparison, essentially, of the two sets of notes that we've looked at over the last 2 days. We're going to compare the critical value approach to the p-value approach and just show the similarities and the differences between these two tests. What you see right now in the red box is what we call the one mean z-test, which is what we've been doing for the last 2 days. And in both cases, we do know the population standard deviation. Tomorrow we're going to look at when we don't know the population standard deviation, and I'm sure you're familiar with when we did some similar work using a known sample standard known standard deviation and an unknown standard deviation in the previous unit. When we're doing the one mean z-test, there are some assumptions that we have to make. One, we have to assume that it is a simple random sample. Two, we're going to assume one of two things. It's either a normally distributed population or we have a large sample size. And then three, we're going to also make sure that we do know what the population standard deviation is. So the first step is to generate the null and alternative hypotheses for the test. The null hypothesis is whatever the claim is that the average is for the population. Then you have three options for the alternative hypothesis. The first one being the two-tailed test, which is not equal to. The second one being the left-tailed test, which is less than. And then the third one is the right-tailed test, where you have greater than. Step two would be to decide on the significance level, which is labeled alpha. And then step three, you compute the z-score that corresponds to whatever your sample mean happens to be compared to the population, the assumed population mean. And then now we kind of break this up into the two different approaches. On the left, you have the critical value approach. With the critical value approach, you have three options. You have the plus minus z sub alpha over 2, which corresponds to a two-tailed test. Negative z sub alpha, which corresponds to the left-tailed test. And positive z sub alpha, which corresponds to the right-tailed test. And then just like we've done for step 5, if the value for the test statistic falls in the rejection region, you obviously reject the null hypothesis. Then on the right-hand side, at the p-value approach, you find the area under the curve that corresponds to your z-score found in step 3. If the p-value is less than your significance level, then you reject the null hypothesis. If your p-value is greater than the rejection level or the alpha level, then you do not reject the null hypothesis. And then step 6, you just interpret your results from the hypothesis test. So we're going to look at example 1. And this is an example that we are very familiar with because we have done this one on several occasions. We've used this data before. So we're familiar with this problem, but what I want to do is go through and label a few things that kind of helps set this problem up easy. So it says that a half century ago, the average U.S. woman in her 20s was 62.6 inches tall. So there's our value from mu. The heights in inches of a sample of 25 of today's women in their 20s is presented. So 25 is our value for n, which is our sample size. By the way, the average for this data is 64.24 inches. At the 1% significance level, so we have alpha is equal to 0.01. Do the data provide sufficient evidence to conclude that the mean height, blah, 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 blah. Assume that the population standard deviation of the heights for today's women is 2.88. One more thing that I forgot to note here, greater than. So we are looking at a right-tailed test. So let's go ahead and kind of follow those steps that were outlined at the beginning of the notes and compare how the two tests should end up with the same result. So the first thing we want to do is state our null hypothesis. And our null hypothesis is that mu is equal to 62.6 inches. Our alternative hypothesis is mu is greater than 62.6 inches. The next step is to label what alpha is. We found that in the problem itself. It's 0.01. And then we want to compute our value for z, which is our test statistic. So we take our sample mean of 64.24, subtract the given mean of 62.6, divided by the sample or the population standard deviation of 2.88, which is then divided by the square root of the sample size, which is 25. And then when we simplify this, we find that it's approximately equal to 2.85. So we've done all the first three steps that we have to do before we can tackle the critical value approach or the p-value approach. So I'm going to make two columns here. We have the critical and then the p-value. And so when we set this up, our alpha is 0.01. So what we want to do is look at our z-table and find what z-score corresponds to 0.01. And remember, since it's a right-tailed test, we're going to have to do 1 minus 0.01 is equal to 0.99. And then so when we go look at the areas in the z-table, we're looking for 0.99. Closest one to 0.99, 2.33. That's what we'll go with. We could go with 2.325. Either one, it's not going to make that big of a difference. It's actually not going to make any difference at all in this case. But we do get that this is going to be 2.33. So we have the z-score that we're looking at. And in terms of the normal curve, what this means, because we're talking about rejection regions with the critical value approach, our z-score of 2.33 is right here. And anything that has a z-score that lies in the rejection region will be obviously rejected by this test. And the z-score that we computed in our test statistic was 2.85. So 2.85 does certainly lie within the rejection region. So our conclusion is that we reject the null hypothesis. With the p-value approach, again, it's very similar. It's exactly what we did yesterday. But in this case, what we do is we find the area that is associated with 2.85. But because we're talking about a right-tailed test, we have to do 1 minus whatever that area happens to be. So let's first go find the area for 2.85, because remember, the z-table provides us with the areas to the left of a given z-score. So we're looking for 2.85. 1, 2, 3, 4, 5. It's 0.99781. And that's going to be approximately equal to 0.0022. So all we have to do now is take that area, 0.0022, and compare it to our significance level of 0.01. We can clearly see that this is less than. So anytime our p-value is less than our significance level, we reject the null hypothesis. And then as far as the interpretation goes for that information, what we're saying is that at the 1% significance level, the data provided the data provides sufficient evidence to conclude that the mean height of today's women in their 20s is greater than the mean height of women in their 20s a half century ago. So we are rejecting the null hypothesis in this case. Example 2 is, again, another one that we are familiar with. It's talking about the calcium intake for adults with incomes below the poverty level. So let's go ahead and label what we know. We see here that mu is 1,000 milligrams. Our sample size is 18. We have a alpha of 0.05. Less than, so we're looking at a left-tailed test. And we have our sigma is 188 milligrams. Again, the sample mean is 947.4. All right, so first we state the null hypothesis, and that's that mu is equal to 1,000 milligrams. Our alternative hypothesis is that mu is less than 1,000 milligrams. This is a left-tailed test. And our significance level, our alpha, is 0.05. And then we just want to compute our test statistic. So it's the sample mean minus the assumed population mean. And that's going to be over the population standard deviation divided by the square root of the sample size. I almost put 25. And when we calculate that, we find that this is approximately equal to 1.19. So now we break up into our two approaches, the critical value approach and the p-value. For the critical value approach, we have z sub 0.05, and in yesterday's notes, I believe I did provide you guys with a table that makes this easier to do than having to go back to the z table every time and find what these values are. But we're looking for the area to the left of the curve. But in this case, remember this notation provides us, we're looking at the area to the right of a curve. So we need to find the area that corresponds to 1 minus 0.05, and that would be 0.95. So let's go to the z table. We're looking for 0.95 in the table. Going to fall right in this region here, which we're going to say is 1.645. But because it's a left-tailed test, we're going to make that negative 1.645. We have negative 1.645. And when we look at the normal curve here, our rejection region lies to the left because it's a left-tailed test. Our value for our test statistic was negative 1.19. And that definitely falls within the non-rejection region. So our claim here is that we do not reject the null hypothesis. And then when we look at the p-value approach, we want to find the area under the curve associated with negative 1.19. And because it's a left-tailed test, we don't have to do anything fancy with the z-table. We just simply go in here and we find the area associated with negative 1.19. And we're going to find that that is 0.11702. We're going to compare that area to our significance level and make the determination based off this information. Since the p-value is greater than our significance level, once again, we do conclude that we do not reject the null hypothesis. And the interpretation simply is at the 5% significance level, the data does not provide sufficient evidence to conclude that the mean calcium intake of adults with incomes below the poverty level is less than the recommended 1,000 milligrams per day. And then we have one more example, and then we're going to be finished with these notes. I'm sure you guys are happy about that. I know you like short videos. So with this one, we're talking about cheetah, the land speed of cheetahs, and we have the information provided within the problem itself that mu is 60 miles per hour. We have a sample size of 35, a significance level of 5%, and we're looking at differs. So when it differs, we're saying not equal to, and we have a sigma of 3.2. So our null hypothesis is that mu is equal to 60 miles per hour. Our alternative hypothesis is that mu is not equal to 60 miles per hour. And our significance level is 0.05. There's our alpha. And then we compute z. The sample mean here is 59.526 miles per hour. So when we set up our test statistic, we have 59.526 minus 60 over the population standard deviation divided by the square root of the sample size. And when we compute that, we get negative 0.88. All right, so for the critical value approach, it's a two-tailed test. So what we need to do is look at z sub 0.5 divided by 2. We had alpha over 2. And so that's going to correspond to, if you remember at the beginning of these notes, a test statistic of plus or minus z sub 0.025. So when we go look at the table, we're trying to find the z-score that has an area to its right of 0.025. So that would be the same as 1 minus 0.025, which is going to be 0.975. So we're going to look for the area of 0.975 in our z-table. .975, we have the exact value, which is 1.96, and so that means that we are going to use plus or minus 1.96 because it is a left-tailed or a two-tailed test. So as far as the normal curve goes, what that visually represents is we have negative 1.96 to the left, 1.96 to the right. Our rejection regions are to the left and the right of those two values respectively. We just need to figure out where does our value of negative 0.88 fall. And negative 0.88 definitely falls within the non-rejection region. So we do not reject the null hypothesis. For the p-value approach, again, we're talking about a two-tailed test. We have a z-score of negative 0.88. So with the p-value approach, we have to find the area that corresponds to negative 0.88. Go back to the table. Negative 0.88 is 0.18943. And that's the area just to the left of negative 0.88, but we also have to consider the area that corresponds to the right. So we just, for a two-tailed test, just remember you find the area and then you multiply it by 2. And when we do the multiplication, we are going to get 0.37886. So we compare our p-value to our significance level. And we can see that the p-value is greater than the significance level, which again leads us to the same conclusion. Do not reject the null hypothesis. And with respect to an interpretation, At the 5% significance level, we're saying that the data does not provide sufficient evidence to conclude that the mean top speed of all cheetahs differs from 60 miles per hour. That's the end of this set of notes. I would like for you to just read over this example here of where the sample size has an impact on whether or not we accept or reject the null hypothesis. Because with this particular example, we're using a sample size of 1,000. So it gives us an idea of how a really large sample size has a greater impact on whether or not we accept or reject null hypotheses. And there's your homework problems. So that's it. I'll get this posted, and we will meet tomorrow in Zoom at 2 o'clock. I would like to see everybody if possible. And I'll be talking to you guys then. So everybody take care.